Okay, for what we have in number 25, okay, I modified the number of inches in terms of the classes, and I will tell you why. Originally you had 5.5 to 20.5, then you had 20.5 to 35.5, and to me, at least upon my training that I have had regarding statistics, again, you cannot have any one integral value to belong in one class and then overlap into another class. And so this is why I'm ending the upper class limits with the number 4, because strictly speaking, you cannot have any value to belong to more than one class, even though it's strongly implicit, about what the ranges are. It's not going to affect the widths per se, but you can't have 20.5 in both the first and second class. I know that like 20.5 might be in reference to like 20.49999, and 20.5 would be like 20.5. Then you have a value that's just maybe right at it or slightly above it, almost tangential. But in the case of the modification, okay, I have adjusted the upper class limits, okay, preserving nonetheless a class width of 15 throughout, and the frequencies are still the same, okay, where we have the total number of recordings to be at 25. Now there will be a different dynamic that is going to be carried out in terms of the determination of the mean as well as the variance and ultimately the standard deviation. Now for what we have in the case of the class midpoints, again that's going to be taking the mean of the lower and the upper class limits, and the first of the class midpoints is going to be 12.95, and you're going to add 15 at a time. Okay, since we're looking at a class width of 15, so we're ranging from 12.95 all the way up to the last of the class midpoints, okay, which will be 87.95. And in the case of after the adjustment of the group frequency distributions upper class limits, okay, in the segue to determining, okay, just what the mean is going to be. Okay, first of all, okay, we have the product of the frequency and the midpoint. Okay, so we have in the set had 25.90 for the first class, second class have 83.85, third class 343.60. Then we have all the way up to the last class, so you have 3 times 87.95. So that product is at 263.85. So you had the sum of the products of the frequencies and the midpoints to be at 1283.75 if we carry out, okay, to the last decimal place. Now for what we have in the lead into the variance calculation, okay, again you're looking at taking the product of the frequency and the square of the midpoint, and in each of these sections can be attained by taking the product of the midpoint and again the product of the frequency and the midpoint, that is taking the product of the previous two column values. So you have 335.405, 27.95 times 83.85, you have 2343.6075. Then maintaining the pattern, okay, saying that for the sixth class you have 87.95 times 263.85, so you have this product at 23,205.6075. and if we were to add all these numbers together, okay, we would have a sum in this case of 76,756.5625. Okay, so in the case of the lead into determining, okay, just what the class mean is going to be, okay, we have again we have for the mean itself, okay, we have for taking once again the sum of the products of the frequencies and the midpoints divided by the number of recordings. In this case we have it 25, so you have 1283.75, okay, divided by 25, and so for what we are going to have in this particular case is for the mean, okay, it's going to be right at 51.35. Okay, now for what we have in terms of the modal class, okay, that again is going to be, okay, the class that has the highest frequency, and in this one highest frequency is going to be at 8, and that is going to belong to the third class, this case, which we have at 35.5 to 50.4. Okay, and in terms of the variance, okay, so you have S squared. Again, you have number of data items times the sum of the product of the frequencies and the squares of the midpoints, and you have minus the square of the sum of the products of the frequencies and the midpoints. And again, we have divided by n times n minus 1. So for what we have for the variance, okay, if we were to plug in accordingly, okay, so we have n is at 25, and we have again, we have for the sum of the products of the frequencies and the squares of the midpoints. Okay, so you have 25. You have, okay, again, 76,756.5625. And you have minus, again, the square of the sum of the products of the frequencies and the midpoints. And again, have all over 25 times 24. Okay, and after substituting and breaking it on down, let's see, taking the numbers as they are. Okay, so you have for the difference, okay, so you have 270,900 divided by 600. And so for what we have regarding the ratio here, okay, we have for the variance, okay, that is going to be, in this case, a 451.5, okay, and thus we have for the standard deviation, okay, that is going to be the square root of this value. Okay, so we have for the sample standard deviation, okay, it's going to follow that S, our sample standard deviation, okay, is going to be the square root of 451 and a half. And so for what we have in this case, that is going to be about 21.2. Or if you take out to the nearest two decimal places, actually, yeah, so you have about 21.25. So again, we have the mean is going to be at 51.35. Modal class, again, is the third one from 35.5 to 50.4. Variance we have at 451.5. And as for the standard deviation, okay, we have right at 21 1/4.